look at the percentage composition by mass of elements in compound. Alright, let's use the same elements we did before now. We got two elements, I think. We got the molar mass of two elements. That was this one, yeah? And put it again there. I think this. Please give me their, what do you call it? This was 12. This was how many? 1. This was how many there? 16. This was what? 39. This was what there? 59, right? 52. Okay, so 52. I had this. Alright. So look at this. Example. Since we've done this already, let's get this. Okay, before that. Pick that please. Pick that. Note something, yes. Let's get the formula before we start solving. Note. The percentage composition of elements of an element. The percentage composition of an element in a compound is given by the formula percentage composition is equal to the mass of the element all over the molar mass of the compound times what there? 100%. Here's the formula, please. Comes mass of the element all over molar mass of the compound times 100% times 100%. This stuff, I was checking the past mission, this stuff came out like how many times? So let's just do it together, right? Let's do it together. Alright. Example. Example. Find the percentage composition by mass. Example. Find the percentage composition by mass of each element in this compound. Find the percentage composition by mass of each element in, you have this. Look at it. Your first task is to get the molar mass. You already calculated the molar mass of this. As how many, please? Huh? 30? Yes. 30 grams of mole. Alright. So the same in Jamb, they won't ask you of each of them. They just ask for only one of them. So maybe of sulfur. Or of just one, but let's do all of them because I want to show you something. Alright, let's start with the first one. Carbon. For carbon, what do you have? You said it's equal to the mass. It's equal to the mass of the element all over the molar mass of the compound times 100. So it's equal to the mass of carbon all over molar mass of the compound times 100%. So it's now equal to mass of carbon, how many there? 12. Comes 12 all over molar mass of this 30 times what there? 100%. Please give me value. 0.4. Huh? Give me the final answer from Martin. That gives you about 40%. Alright. Let's take for hydrogen. For hydrogen is now equal to the mass of hydrogen. How many there? 1. But look at it. In this compound, how many atoms of hydrogen do you have here? 2. becomes times 2. Please don't forget this. Becomes times 2. Times 2 because I have 2 atoms of hydrogen here. All over molar mass of the compound 30 times 100%. That's now equal to 2 over 30 times 100%. Please give me value. What do you get? 6.67%. Finally, for oxygen, that's now equal to mass of oxygen, that's 16. So 16 all over molar mass of the compound is 30. This times what there? 100%. So it's equal to, this is the final answer. 50 what? 3%. Alright, so I said in case of Jamb, you'll not be asked to find all of them. You have to find one. If they say oxygen, go straight to oxygen. So first start, get the molar mass first. Go straight to oxygen. You have to start doing all of them. Now, this is what I want to show you. Look up. Look up. What's this value here? 40. So let's do 40 plus, what's this value here? 6.67 plus how many here? Is equal to, combine this, what do you get here? Gives you 100%. So that means if I sum up the percentage of what all the elements, gives you what there? 100. That's it. Yeah.
So is it the same with other?
Yes. Yes. Even if let's say if you have like 7 elements, get each of them, their percentages there, combine them to give you 100%. What does 100% mean? Is what a total makes sense. Should be 100%. So yeah. When you're trying to do that, please. Oh, that's something. Hold on. Was this 3 or 3? Which of them?
3.
If you use 3, yeah, it give you 90. It will give you 99 point something, is it not? Yes. So yeah, just get to me quick. What you're doing is use the same number of decimal places. That's the concept. If I'm using 2 decimals here, use 2 decimal here. If you use 2 decimal and 1 decimal, to give you close to 100, but not exactly 100. So 3 will give you 100%. So use equal number of decimal places. If you use 6 point, let's say I want to use 1 decimal here to be 6.7 and then 3.3, it still give you 100%. So use equal decimal places. Here's a whole number, so no decimal. So it's the same thing. Alright, let's just do Jamb standard. Let's do, think that please. Now listen again though. Another way of them asking question in Jamb, they now say, which of the following contains the highest percentage by mass of the element in this compound? That's another way of asking a question. They'll say, which of the following elements contains the highest percentage by mass in this? You ask the question. Is it carbon? Is it hydrogen? Is it oxygen? In this case, now you have to be very fast. Alright, so be fast, look for all of them, and then compare. So for this now, which one contains the highest percentage? Carbon. You can see. Carbon is 40%. This one is 6.67. Okay, sorry, that's oxygen, Abi? Sorry, oxygen. Oxygen has the highest percentage, 3.3. Now, this is the popular deception. So now come and say, okay, look at this. It should be hydrogen now. After all of them they are 1, hydrogen is 2. That's not true. So observe, the atom that has the highest number of elements is what? Hydrogen. It has the highest number of elements, but yet the least composition. So don't think that since an element has 2, you should have the highest number. No, it doesn't work that way. It does not. Alright, so the number of atoms is not always equal to the highest percentage. In this compound now, oxygen might have the highest composition here. Does not mean it has the highest by mass composition. Right? That's the concept. Alright, let's try for this please. Number 2 please. Number 2. Find the percentage composition by mass of chromium in this compound, yeah? So I said I will show you how to teach you how to name them in the next class or so, right? Potassium heptadioxide dichromate 6, that's the compound, yeah? What is this with? For this, of course, we already got the relative molecular mass. As how many there? For this was what there? 300 294 gram per mole. Already got this one, yeah? Alright. It's asked for which of the elements, please? So go to the chromium. So for chromium, that will be equal to 52 times what there? 2. I have 2 atoms of it. All over the molar mass. 294 times what there? 100%. This time gives what there? 104 all over 294 times what? 100%. Please give me value.
35.37.
Huh?
35.37.
what there? That's it. This is how they give it in Jamb. I'll post some question in WhatsApp group. Let's do this. Let's revise some past please. Alright. Number 1. These are Jamb question. Number 1. Number 1. How many unpaired electrons, number 1, from Jamb past question, how many unpaired electrons are in the p orbital? How many unpaired electrons are in the p orbital of a fluorine atom? Are in the p orbital of a fluorine atom? Of a fluorine atom? Of a fluorine atom? So this is actually, when you hear p orbital, what comes to mind there? SPDF configuration. For fluorine, fluorine is atomic number what? Number what? 9. Abi? If it's atomic number 9, please help me with SPDF configuration. What's the, I give you the procedure, what's the arrangement? 1s, Abi? Next up, 2s, next up, 2p, next up, 3s, Abi? So if I'm having fluorine as atomic number 9, fixing 9 here. What we have? 2 maximum. How many left? 7 left, Abi? Yes. Right, so 9 are fixed to 7 left. Put 2 here. How many left here? How many left? This is 2, 2, 4. I'm also filling 9 electrons. I've filled in 4. How many left there? 5. So I have, that means there's no 3s atom. It's just 1s squared, 2s squared, 2 p power 5. Imagine somebody that just come to class today for the first time. Will you understand what I'm doing here? You will not. You will not. Alright. Let's draft this stuff here. So I have what there? 1s squared. That's this and this, Abi? Next up, 2s. That's 2s. 1 up, 1 down. Next up, 2p. Please, for the p, how do I go about this? Do I? Okay, that's this, Abi? And hang on. That's this, 2p. Please, do I fill it 1, 2, 3, 4, and 5? Or do I go all of them first? Abi? I'm going to take off first. And you see what there? 1, 2, 3. Fill off first. Then 4 and 5. He asks you how many unpaired. Is how many unpaired here? Just 1 unpaired. My answer is 3. 1 unpaired. The answer is number 2. Number 2. Calculate the percentage composition of oxygen. Calculate the percentage composition of oxygen in calcium trioxo nitrate IV. Calculate the percentage composition of what? Oxygen in calcium trioxonitrate IV. That's 4. Lucky enough, they gave you Ca as 40, give you C as 12, give you O as 16. Alright. This is clear now. For oxygen. Now the problem is now this. They didn't give you the compound in its formula form. They gave you the compound in words. So the first way for you to fail this is for you not to even write the formula correctly. Immediately just miss the formula, forget it. Forget it. So the question is this now, if I have calcium triisocarbonate 4, what's the compound? What's the formula for this man? Huh? CNO3. How sure are you? Calcium is Ca what there? 2 plus, Abi? When I give you radicals, I give 4 trials nitric, Abi? Check, what was this in there? NO3. How many, what was there? Minus. Was it minus or 2 minus or what? NO3 minus. Right? Right. So if it's NO3 minus, cut out. If you now cross, what will happen here? What will this give you? The 1 comes this way. It gives you what there? Ca. This 2 goes to this, Abi? This one there. NO3 2. So your stuff there was wrong. That means you wouldn't have gotten the answer correctly. Gives you Ca in brackets NO3 close the bracket 2. Now I said this one is very interesting, and this is why I have to show this one here. Right, so when I know how I'm following up my teaching, such that you can. So please make sure you're studying these stuff, studying them. I'm having this one here. So what's the next task here? It's trying to find the percentage composition of what? Of oxygen. Your first task now, expand the bracket. If I expand bracket, then this gives you what there? Ce and 2 comes in, gives you what there? 2. O into 3 times 2, 6. I'm having this by expansion, alright? 2 times 1 here, that's 2. 2 times 3 here, that's 6. Next up, for percentage composition, I need 2 things there. I need the mass of the element. I also need what again there? Molar mass of the compound. So get molar mass of this. Molar mass of this compound is equal to calcium. Atomic number what there? 40 plus nitrogen. Number what there? Was it given? No? What are we giving here? Oh, I think it's actually triisocarbonate, please. Triisocarbonate, sorry. Not nitrate. Triisocarbonate. Please. Triisocarbonate, say NO3 or what then? CO3 minus. Please check your notes. CO3 minus. You might have 2 minus. 2 minus. Now I give this thing, so 2 minus. Let's work with this. Alright. So what would happen here? This one comes to a B. So 2 here goes this way here. So what happens here now? We'll cancel out. This would have been C here. Abi? We'll cancel out. So it gives you what there? CO3. That's what there. I give this compound 4 now, Abi? Yes. Yes, CaCO3. Carbon, how many there? 12 plus oxygen, how many there? 16 times 3. This will give you how many there? 40 plus 12 plus 48. In total, 100 grams per mole. For oxygen, as you're asked to find, for oxygen becomes equal to the mass of oxygen. Of course, times how many here? 3. That becomes 16 times 3 all over molar mass of the compound 100 times what there? 100%. This is equal to this and this 48 over 100 times 100%. This will cancel this. That's why I got what there? 48%. 48%. 48% here is option B. Alright? I didn't give you option on this one. That's actually option B here. That's 48%. Can we try more? Should I give you this assignment? Assignment. Alright. So assignment then. You want to do this stuff so you see how this works. Okay. Alright then. So I think we'll call it a day. See you tomorrow. See you next week.